Hello, Washington Liberty Chemistry students. This is your Unit 2 lesson on density. So the definition of density is the degree of compactness of a substance measured as the mass per unit of volume. It is an intensive property that does not depend on the amount of matter. Now, density is a derived unit because it combines two base units, mass and volume. Now, in terms of the definition of density, you should remember that substances that are less dense will float in substances that are more dense, regardless of the mass. So density is the compactness of the matter, not the mass of the matter. I'd like you to watch this very short video on making a density tower and seeing how things that are more dense tend to sink and things that are less dense tend to float.
Today, I'm going to show you a simple science experiment that you can try at home to learn about density. Start by taking an empty glass and tip in some water and food colouring. Then add some syrup or treacle. And I'm going to add a little bit more water to make the layer a bit thicker. Then finally, fill the glass up with some oil and leave it to settle for about 15 minutes. These liquids separate out into different layers because they're different densities and they don't mix. The syrup has the highest density, so it sits on the bottom, and the oil, which has the lowest density, rises to the top. Try dropping different objects in to see what happens. If we drop this metal nut in, which is really dense, you can see it sinks right to the bottom. But if I take this grape and drop it in, it sinks through the oil and water, but sits on the syrup. This is because the syrup is denser than the grape. Pretty cool, huh? Now if I take this plastic bottle top and drop it in, it slowly sinks through the oil and sits on the water. And finally, if I take this piece of sponge and drop it in, it sits on top. The oil is denser than the sponge. You can try dropping different objects in to see which fluids are denser. I also found shining a torch beam down from above gives a really nice effect. I hope you've enjoyed watching this video. If you want to see more, today I'm going to show you a simple...
All right, so let's talk about the units of density. As I said, it was a derived unit. So for solid, the unit of density is usually expressed as grams per cubic centimeter, and it can be expressed either like this or like this. Strictly speaking, this is how many grams per 1 cubic centimeter. For liquid, because we measure liquids in milliliters, it's usually expressed as grams per milliliter or grams over milliliters. Now you should note that a milliliter is a cubic centimeter. In other words, if you have a cube that's a centimeter by a centimeter by a centimeter and fill it with a liquid, that's the equivalent to 1 milliliter. Now the equation for calculating density is density equals mass divided by volume, with D standing for density, its units being grams per milliliter or grams per cubic centimeter, M for mass, which is grams, measured in grams, and V for volume, which is either milliliters, sometimes it's liters, and oftentimes for solids, it's cubic centimeters. And again, note, 1 milliliter equals 1 cubic centimeter. So really, a gram per milliliter or a gram per cubic centimeter is really expressing the same thing. Now I want to show you a really cool little trick that is a shortcut for algebra in terms of solving that density equation. And it really helps to keep it straight and to make sure that, especially when I'm asking you to solve for the denominator, that you don't do it wrong. So you set up a triangle like this and you divide it into these 3 sections, and density is here, mass is here, and volume is here. It's very important you put them in the right sections. And essentially what you do is you can cover the thing the problem is asking for, and it tells you the operation that you should do with the other 2 variables. For example, if I wanted to solve with density, I cover up density, and what you would see left here is mass over volume. So I would know that in order to calculate density, I would need to take the mass and divide it by the volume. On the other hand, if I wanted to solve for mass and I cover up mass, these 2 things are next to each other. So I know to solve for mass, I would have to take the density and multiply it times the volume. You'd solve for M. And then to solve for the volume, you cover up volume, and this is the one that people have the most trouble and will often get backwards, is solving for volume. To solve for volume, volume is going to be mass divided by density. So again, here's your density triangle with density equals mass divided by volume. So let's try a problem. If the volume is 2 milliliters and it weighs 4.6 grams, what is the density of the substance? So again, we've just got to identify, using the units can be helpful, what we're solving for. We're solving for density. So take a minute and see if you can do this. Use the right number of significant figures. It's division, so we're going to have 2 significant figures in our answer. Have you been able to solve for it? Again, this is the mass, this is the volume. If you solve for it, you will get 2.3 grams, because 4.6 divided by 2 would give us 2.3 grams per milliliter. And again, that's the unit of density. In other words, it means that this substance, for every 1 milliliter of it, it weighs 2.3 grams. Okay, so let's look at another one. If density is 4 grams per milliliter and it has a volume of 1.5 milliliters, what is the mass of the substance? Okay, so this time we're going to solve for mass. So again, we're going to solve for mass, so we'll cover mass, and that shows us that density times volume is going to give us mass. So if the density is 4 grams per milliliter and has a volume of 1.5 milliliters, what's the mass of the substance? So you're going to do a multiplication. Can you do that in your head? You should get 6.0 grams, because 4 times 1.5 is 6. And you'll also notice, if you notice the dimensions, that the milliliters will cancel out and leave you with grams. Okay, let's try one more. Okay, this time it says if the mass is 4.5 grams, it has a density of 1.5 grams per milliliter, what is the volume? So we got to solve for volume. So we'll cover up volume and see that it's mass divided by density. And then, so we got mass is 4.5 and density is 1.5. Again, can you do that in your head? So your volume would be 3.0 milliliters, because 4.5 divided by 1.5 is 3. Okay, now we're going to be doing some labs where we're going to have to experimentally find the density of a liquid and the density of a solid. So let's first figure out how you would figure out the density of a liquid. Because again, you can make these wonderful density columns where you can stack things that are more dense on the bottom and less dense on the top and make these really beautiful density columns. But how do you find the density of a liquid? So number one, you're going to measure the volume of the liquid using a graduated cylinder. That's what this is. It measures volume. Again, make sure you're doing it to the right number of significant figures. You're recording all the marks and one estimated digit. You're going to measure the mass on a scale. So you'll measure the mass of the liquid on the scale. And again, you'll have to be careful of that, because when you put it on the scale, you'll need to make sure that you subtract out the weight of the cylinder. You're not going to be able to pour the liquid directly on the scale. So you'll either have to put the cylinder on and tare it or zero it first, or you'll have to weigh the cylinder and subtract out. Third, you'll divide the mass by the volume. That's the definition of density. So you know its volume, you know its mass. And finally, you will remember that the unit of density for a liquid is usually grams per milliliter, although it would not be incorrect to say grams per cubic centimeter, because a cubic centimeter is a milliliter. All right, now how do you measure? Again, just as a review, you always measure at the bottom what's called the meniscus. So the because the fluids are often attracted to the glass or the plastic on the side of the graduated cylinders, they don't go into the graduated cylinder evenly. They tend to be a little bit attracted to it, and so you get this kind of bow shape. And you always measure, the agreed upon standard is that you measure at the bottom of the meniscus. So this particular volume, you can see you have 30 here, 30's on top, and then you got 31, 32, 33, 34, 35, 36, and so the level is between 36 and 37, so I would read that as 36.5. Again, we have all the marks, all 36, and one estimated digit. So what would you do for this one? Write down what you think you would do for this particular volume and see if you're right. Okay, so I would have put 56 again, because this is 50, 51, 52, 53, 54, 55, 56, and I would have put 56.0 because that looks like it's almost exactly on the line. However, I know that I can estimate one more digit, so I have marks to the ones place, and so I have to estimate to the tens place. Since I think it's kind of almost exactly on that line, I'm going to say 56.0 milliliters. Okay. Now, another thing you're going to have to do in the lab is you're going to have to find the density of an irregular solid. obviously you've learned your geometry, and if you have a regular solid, like a cube, you can find density by, you can find volume by measuring length times width times height. But what if the object that you're trying to find the density of is irregularly shaped and it's harder to find the volume? Well, the first thing you'll do is you'll take that object and you'll weigh it, because you do need the mass, and that's pretty easy to do if it's a solid. Second, you're going to measure the volume of this irregularly shaped solid by using something called water displacement. And you'll be sure to subtract out the original water volume. And then again, same thing, you're going to divide the mass by the volume. And the unit for solids is usually grams per cubic centimeter. Now, how do you find the volume of a regular solid? Well, again, let's talk about what water displacement is. So look at this graphic here. So we've got this irregularly shaped solid. It's not a perfect cube or a perfect sphere where we can take measurements of radius or length or depth or height in order to find the volume exactly. It's irregular, but it does have a volume. It does take up space. So you take a graduated cylinder and you fill it to a certain amount that you know. So this graduated cylinder is filled to 7. Then you're going to drop the object in, and you'll see that the water level will rise, and it rises the exact amount of the volume of the irregular solid. So the water rises 2 units, and therefore this object has a volume of 2. And again, note, we would have to do 9 minus 7 to get that number. In other words, we started at 7, it rose to 9. That means the volume that we dropped into the graduated cylinder was 2. We displaced 2 milliliters of water. All right, so let's try another example here. The initial volume of a graduated cylinder is 11.5 milliliters. A solid object, like this little pebble, is dropped into the water, and the water rises to 14 milliliters. What's the volume of the solid? Write down your answer. What you would do is you would subtract 14 minus 11.5, and that would give you 2.5 milliliters, or 2.5 cubic centimeters. Now, let's just complete this problem. Now, suppose you weighed this little pebble and you found that the mass of this object was 10 grams. So what would its density be? You have volume and you have mass. Can you figure out what its density would be? Can you express it to the right significant figures? Can you put the right units on it? Give it a try. I think you should be able to do this without your calculator. So we know that density is mass over volume. We have 10 grams. That's 4 significant figures. We have 2.5 centimeters cubed. That's just 2 significant figures. So 10 divided by 2.5 is 4.0. Again, matching significant figures here because it's a division. Grams per cubic centimeter. And that is your lesson on density.